All right, so let's put this back together. Bryce, what was the ratio that or proportion you set up? 15 over x is 21 over 12. I am not going to agree with that. Okay? Do not see how these are separated like almost completely across the triangle. That's not the pair you want to use. They have to be on the same side of the angle bisector. And actually, this is probably a good way. Let me actually erase that. I want to do that one again. I never thought about this before. Truly never thought about it. If you extend the angle bisector, pair them up because they're on the same side. So 12 and x are paired together. So Bree? So x over?
12 over x.
Okay. All right, Bree, tell me which one. Is it x over 12 or 12 over x?
12 over x equals 15 over 21.
I agree.
And then 15 over 21 are reduced to 5 over 7.
Okay.
And then you get 5x equals 84.
All right.
Divide by 5, and then the lowest you reduce to is 84 over 5.
I agree.
That's all by myself.
Good job, Bree. What? No, I was like trying to envision the whole thing. Okay, guys, the last problem here is a little tricky. This one actually is a really tricky problem. Why is this different from the others? Yeah, we don't have the other half, right? We don't have this part right here. Good job, Justin. Thomas? Sure.
Okay, it'd be 15 over 18 minus x equals 10 over x.
Absolutely. Now, I'm going to, before we solve this, I want to make sure we take the time and explain where 18 minus x comes from.
That would be a whole, only part of it, then you guys subtract parts of it.
Exactly. I'm going to go ahead and kind of go almost from a piece of wood, okay, a board. Okay? And if I tell you this board is 18 feet, and this portion is 5 feet, what's left over?
13.
How'd you get that?
5 minus 13. I did 5 minus 18.
You did 18 minus 5, right? So if I have an unknown length, x, what's the other side?
18 minus 7.
That's 18 minus x. It's the same concept. Okay? So once you want to start making that connection, that just because you're not always given something, doesn't mean that you can't write an expression to represent that missing piece. All right, and that happens a lot in geometry. So that's one of those skills, those little tricks of the trade that you need to remember. All right, guys, so here we go. Let's go ahead and cross multiply. So we get 15x equals 10. Guys, this is where you got to be careful, all right? You got to make sure you understand how to write mathematics.
No, parentheses come first.
Yep, so you got to make sure you write it as 10 times the quantity, 18 minus x. Why are you interrupting my class? Maybe we should have passed it the first time we took it. So if you guys keep taking these, I'm not going to have any more copies left. So I think it's bad. All right, can you guys solve it from there? No. Claire, what do you mean no? All right, guys, here we go. Bree, go ahead.
Okay, 5x equals.
Whoa, slow it down there.
Or 15x
So 15x.
equals, and then you'll take 10 times 18
we gotta make sure we distribute.
Okay, and then you'll get negative 10x.
Okay.
And then you will add 10x,
Uh-huh.
15x, you get 25x, equals 180.
Okay.
25.
X is 180 over 25. Can that be reduced?
Gets 5.
So what does that give me?
You get 35 over
36 over 5.
5.
Alright, any questions on that? Okay, so we got 4 examples of this in your notes.
Go back to the one.
Alright, so go back to number 8.
Yeah.
Whatever number you told us you remember.
Yeah. Go back to that.
Okay, alright, number 6. Okay, guys, here we go. So look at number 6. How would you set up this problem? So x over x plus 3 is 4 over 6. Can that be reduced? Yeah, to what?
2/3.
2/3. Okay, now what? Cross multiply. Okay? Okay? So 1x is equal to 6. Voila!
Ooh. Ooh.
Alright, now, the last part of our notes, I have 3 slides I want to go over with you guys. I want you guys to put on your thinking caps, because this is not going to be a direct instruction sort of deal. I mean, I'll be up here kind of walking you to be guided, not so much here's the relationship, where I'm going to walk you guys and guide you to forming your own concept. Alright, there is a major concept I want you to learn about the ratios of the perimeters versus the ratio of the areas. So, let's start off with squares. So squares are very simple. At least I would think so. So, I want you to complete this slide. Find the perimeters of square A and square B. And then I want you to find the ratio of the sides of A to B. And then I want you to find the ratio of the perimeters of A to B.
Okay.
Square A.
Here we go. What is the perimeter of square A? Shay.
12.
12. 3. What is the perimeter of square B?
24.
24. Okay, good. Alright, keep moving on. Sebastian, what is the ratio of my sides of A to B?
1 to 2.
So A over B is equal to what?
1 half. They're 12 over 24.
No, that would be the ratio of the perimeters. Ratio of the sides.
Oh, 3 to 6.
3 to 6 reduces it down to
1 half.
1/2. Good. Alright, so, Caitlin, what is the ratio of my perimeters? So the perimeter of A over the perimeter of B is what? So 12 over 24, which reduces down to 1/2. What did you notice about the ratio of the perimeters versus the ratio of the sides? It's the same. Make sure you understand that the ratio of the perimeters is equal to the ratio of the sides. Now things are going to get weird.
Uh-oh.
That's fairly simple. Understand that the ratio of the perimeters is the same as the ratio of the sides. Okay. Now, so guys, let me ask you this. Let's say I had, where's my next one. Do the same thing, but this time, what are you doing?
Areas.
Doing the area. How do you find area of a square?
Base times side.
Side times side. Okay, figure that out. Spencer,
Yeah.
what did you get for the area of A?
9.
9. Very good. Shannon, what did you get for the area of B? No, we're not adding here. Remember, you need to multiply. 6 times 6? 36. Okay, very good. So, earlier we said that the ratio of the sides of A to B, A over B, 1 half. Now, if you take the ratio of your areas, the area of A over the area of B is 9 over 36, which is 4. How does 1/4 compare to 1 half? You are correct, but you're wrong. This is the wrong connection. Okay? Right now, it's not really obvious what the connection is. That's because of the issue with the 2 and the 4. But I'm going to challenge you guys a little more. This time, follow me on this. I'm going to eliminate the 6. I'm going to replace it with 9. Repeat that now with 9.
81.
Okay? So now if I do that, that's 9 over 81, which is now 1. Okay, guys, now follow me on this, please. Quiet. The ratio in the beginning was 1/3 or 1/2, correct?
Yes.
What is my ratio now? How do you go from 1/2 to 1/4 and from 1/3 to 1/9?
Times it by 3.
Sebastian? You square it. Guys, this is the big idea. The big idea with ratios are basically with the perimeters and areas of similar figures. Big idea. The ratios of the perimeters of similar figures is R. Whatever the ratio is, it's the same thing for the perimeters. But what about for the... Oops.
Oh, look at that.
But the ratio of the areas is the square of the ratio.
The ratio square.
So, I mean, it kind of makes sense. If I tell you that I have tripled my length, what have I done to my area?
You triple.
No. If I tripled my length, what have I done in the area?
You.
9 did.
I multiplied it by 9. If I take my sides and multiply by 4, what have I done in my area? Multiply by 16. Because you squared the ratio. So guys, it's really important. Okay, now how many guys are in any kind of like digital electronics? Or really think that kind of stuff is pretty cool, okay? So let's say you start designing something and you want to double, you want to make it twice as big. What's the problem? If you have those settings, think about this for a minute. If you want to make something twice as big, you think, oh, just double all the sides. Well, what does that actually do? It makes it 4 times as big. If you double the sides, it makes it 4 times as big. So you can't use 2 as your multiplying factor.
What if you only have 3 sides?
If you have a triangle, you multiply everything by 2. It doesn't matter. The area of the triangle has now been quadrupled.
Wait, so if you only double one side, would that work?
No, that's one. Okay, now we're just being silly. Okay? Guys, that's the big ideas I want you to take out of today's notes.